So today we're going to focus our division polynomials using synthetic division. It's going to be a faster way, and synthetic division only applies to linear factors. Let me clarify what we mean by that, but it only applies to things that look like this. It has to be, and the linear factors, the a has to be 1 every single time. So I can have x minus 2, I can have x plus 3, but I'm not going to say 2x minus 3. I can't divide by a 2x minus 3. It has to be a linear factor whose a is 1. So there has to be a 1 in the front. So notice all these problems here. I'm dividing by a number, or excuse me, a polynomial. It's a binomial, and it has a 1 in the front there. So the setup. The book is going to set it up slightly different than how I'm setting up, but it's going to be exactly the same process. So here's what we do. I'm going to take, what you do is you take the coefficients of everything, including the constant there. So I'm going to take the 2, the -5, and the -3, remembering that if there is any missing terms, you fill it in. So if there was a quadratic gone, I would put a 0 in its stead. All right, now I'm going to put a box around it. Notice that, or a half box. Notice that I'm leaving space underneath. Leaving space underneath because we're going to fill in some things there. And now, here's what we do. We take the opposite of what we see there. Effectively, what we're doing is taking the 0 of that one, right? So I see a -3, so I put a +3 there. Now, the first big step is nothing big. All we actually do is always drop down the first term there, whatever it is. So that's a 2. I'm going to bring that down. Now we're going to repeat the next rhythm, this next rhythm, until we get all the way through everything. So we take this number in the very front here, the 3. I'm going to multiply it this way. So we multiply it this way, times, and we place it there. So it's kind of this bounce that happens. 3 times 2 is 6, so I write 6 right there. Next, we're going to add down. So the rhythm looks like this. We always multiply diagonally, we bounce the answer there, and then we add downward. So I see that when I add 6 minus 5, I get a +1. Now I repeat that whole thing again. I take the 3, I multiply it by 1, and I bounce the result over there. So that gives me a 3 here. Next, I add downward, and notice what we get? We get a 0. So, what's my final result? Just to give you a perspective, if I were to look at this very first term up here, a 2x squared, and I'm essentially dividing by x. So that means this quadratic will drop down to a linear. So this is now a linear. It's 1 less in terms of its term. So my final answer is this. What I did was went from quadratic, and I just changed that to a linear. This used to be the linear, now it's the constant. This would have been the remainder if there was a remainder. We can do a quick check. X minus 3 times this will get me back to where I started here because there's no remainder. All right, so let's see it again in this context here. Again, we take our coefficients, including the constant there. So a 1, a 2, a -15. I'm going to place a box around it, like so, and I'm going to take the opposite of what I see and place it over there. So I put a 1 there. First step is to always drop down the first one, so the 1 comes down. Now we multiply and bounce the result over. So here is a 1. 1 times 1 is 1. And now we add these two together here to get 2. Excuse me, try that again. 3. And now we repeat. 1 times 3 is 3, so I place the 3 over here. And now I add those together to get negative 12. So now here's my result. My result is the 1 becomes just 1x, the 3 is positive 3, and then the remainder is negative 12. So a benefit of synthetic division has to do with us evaluating. So let's recall what evaluating a polynomial function means. If you want to evaluate a function, in this case we'll call it p of x, usually the p there just means polynomial, but it doesn't have to mean anything in particular. And if we want to know at a particular value of x, all you do is substitute it in, and then you simplify until you get an answer. So p of 3 is going to be 12. You put something in, something comes out. However, there's another super secret method for us algebraites, and it looks like this. It's kind of ugly sounding, but it looks like this. If you divide p of x by any of degree, make sure the n has to be greater than 1, so it's not a constant, in other words. And we're dividing it by this factor right here. It's the same as plugging in the a. And the answer is the remainder is going to be the result. So sounds confusing, much easier the moment we do it. So first I'm going to take, here's my function, and I want to evaluate it at 3. So what I'm going to do is just plug in the 3 there, there, and there, and simplify. Okay? So that's going to look like this. P of 3 is equal to 5 times 3 cubed minus 12 times 3 squared plus 2 times 3 plus 1. So here's our old school method. We just take the 3, substitute it in. Remember that when we're doing our order of operations, the grouping symbols come first and then exponents. So I have to cube this first, square this first. So don't say 5 times 3 and then cube it. So in this one, we get 5 times 27 minus 12 times 9 plus 6 plus 1. 135 minus 108 plus 7 equals 34. So this function, when you insert a 3, out comes a 34. All right, old school method, no big deal. The problem, what you might think about this, is sometimes you have to deal with the cubes, you have to deal with order of operations, things might get a little bit confusing. What we're going to show you is that we're going to do exactly what we just taught you, synthetic division, and the last number you write down is the result. So let's set this one up. Remember, we take just the coefficients. So I take the 5, the negative 12, the 2, and the 1. But what we're doing is we are going to take exactly this number and place it right there. So essentially what I've just done is I'm dividing by x minus 3. Remember, we take the opposite of that and we put it in. Okay, so now I just do exactly my synthetic rhythm. So I bring down the 5, multiply out to get 15, bring this down to be a 3, multiply that out to be a 9, bring down my 11, bring over my 33, add those together, and what did I get? 34. Notice over here, dun 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 dun, I got 34.